eliminate the need to draw our Lewis dot diagrams in order to form bonding, because calcium is 2 plus and chloride is 1 minus, because as we looked at yesterday, they're valence shells. Calcium can give 1 electron to chlorine, which becomes chloride with 8 electrons, and so is 1 minus, meaning it has 1 spot to take electrons right there. Calcium, however, is not finished. Calcium can give another chlorine its other electron right here to make another chloride. Do this really quickly for you. Yeah, there we go. And it's going to end up being calcium 2 plus with no electrons. That's why it's got 2 spots right there. So cleaning this all up a little bit, if I can find an eraser, I don't know where I'm looking for. There's an eraser. Let's do the big eraser. If we simplify all of that, knowing that that's what this means, we can do this with the puzzle pieces really quickly. We can see that this chloride fits in really well there, and that 1 minus takes up one of those 2 pluses. But you can see this is not a complete puzzle. What do I need? I need another chloride. And so I end up with that. And now I know that I have a molecule that works, an ionic compound that works, and I can write the formula. I have 1 Ca, 1 calcium, 2 plus. I have 2 chlorides, and so I write the formula. Just as it is, it's the number of ions in the compound. 1 calcium and 2 chlorides. And the name is just the name of the metal. Sorry, I forgot to count these. 1, 2. The name of the metal, calcium, and the name of the ion. This was chlorine, but chlorine only has 7 valence electrons, so when we change this and give it an extra electron, we change the name and we give it the ending IDE, which our pieces already have, calcium chloride. So we have the name. Knowing that, let's do another one here. Knowing that, let's do another one. Let's do the compound between, I don't know, sodium and sulfur. Copy. Let's do those guys here. Sodium and sulfur. I want you to write the name and formula for sodium, the compound between sodium and sulfur. Well, I figure that this sodium can fit nicely right there, but that's not complete, so I need another one. I have sodium and sulfide. So if I was to follow Mr. Taylor's example, I have 2 sodiums, and 1 sulfur, so that's the formula. The name is the name of the metal, doesn't change, sodium. Sulfide instead of sulfur, because sulfur has gained electrons. So the name of this is sodium sulfide. So in today's example, when you get your worksheet and I say, what is the name and formula? You write the name and formula. I don't necessarily need to see all the drawings like we were working on. You can use your puzzle pieces to figure out the formulas, and they already have the names written out, so you're good with that. You may need to work with a partner if you don't have quite as many pieces. These ones fit together in 2s and 1s. Some of them you need 3s and 4s and more, and you might need to use some other people's puzzles, but hopefully you've got enough. The second part of today's work is going to be balancing a chemical equation, and balancing is slightly different. It's not too difficult. But we saw that whatever goes into a reaction needs to balance, needs to be the same as what comes out. For instance, if I put 10 grams of stuff in, I need to get 10 grams out. It can't go anywhere. It doesn't disappear. It's never created or destroyed. And so, let's do an example with this sodium sulfide. Control C. Come down here. Let's see. The things that go into a product or into a chemical reaction are called the reactants. That's on this side of a chemical reaction. I'm not sure why there's a delay. The things that come out of a chemical reaction are called the products. And I can't make something if it wasn't there before. It's not created or destroyed. And so, if my product, if I'm asked to make sodium sulfide, drag these over. We made sodium sulfide, but if you remember what happened, I didn't start. Wow, this is really quite lagging. I apologize. I didn't start with that. We started like this, just with one sodium and one sulfide. And they weren't together yet. Well, one sodium and one sulfide can't just make, it can't make sodium sulfide two sodiums, right? I had to start with two of them. I had to start with two sodiums, right? I had to start with two sodiums. So I did that little clone trick and made another one. So when I write a balanced chemical equation, I just do the same counting, but instead of making Na2S, because these are all pieced together and so they're all written together. That's what's made in this reaction. When they're not together, I have sodium and it's reacting with sulfur. And that's probably what you're given. You're probably given something like this. Sodium reacts with sulfur to produce, and you had to figure out what are you producing. Then you have to make sure it balances. Well, if I make something with two sodiums here, I needed to have two sodiums here. So to write Na isn't fair. And if I write Na2, that's not right because these two aren't linked together, right? This is not linked together right there. They're separate sodiums. They're two different pieces. And so instead of writing my 2 on the bottom, which means they're linked together, I write the 2 up here. I have 2 pieces of sodium plus 1 sulfur, making a sodium sulfide, which is all of them pieced together. So that's one formula, 1, 2, 3. Sodium 2, sulfur 1, 3 pieces stuck together. That's a balanced chemical reaction, and that's what we're going to be doing. Let's try one more of those. Okay, now we got our aluminum and our oxygen. Well, I want to react aluminum and oxygen. And if I'm going to react aluminum and oxygen, I need to put them in as reactants. And then they're going to come out as products. But in order for them to come out as products, we need to figure out how are they made. Well, we can put this one together here. Apparently I didn't make that quite big enough. That looks a little better. It's frozen again. If I put that one in here, well, that doesn't work because I still have an extra piece, so I need more aluminum, which is what we worked on at the beginning and yesterday. Find another puzzle piece. And that fits a little better, but I still need another oxygen. I shouldn't have resized them. And there we go. We have our product, the aluminum oxide. So we now can see that aluminum oxide consists of 2 aluminums. So the product you had to write the name and formula for the products. Al2, notice there's 1, 2 of them, and there's 1, 2, 3 oxygens, so it's Al2O3. The name is aluminum oxide. Right? Well, I started with aluminum, and I reacted it with oxygen, and that made aluminum oxide. Now, this is the right formula. I can see that I have my pieces all fit together nicely. I have to have 2 Als and 3 oxygens for this molecule to work, this ionic compound to work. Problem is, I can't start with 1 aluminum and end up with 2. I can't start with 1 oxygen and end up with 3. Whatever I have at the end, I have to have at the beginning. So I must have had 3 oxygens. I'm trying to find a new color here. I must have had 3 O's, and I must have had 2 Als. I must have had 2 Als, and so I end up, I need 3 of these guys. I had to have 3 of them over here. They're all separate, mind you. This will move. It refuses to move. There we go. And I must have started with 2 aluminums. Now again, yours isn't as easy as just, hey, saying, here, machine, make me another copy. You might have to work with both your sheets. You might need to work with a partner to try and figure out how to balance. Maybe you can just figure it out in your head. But we had 3 oxygens and 2 Als, and we pieced them all together to make 1 Al2O3.